Awesome. Awesome. So Dr. Moasani does not need any introduction. I'm sure John and Diane, you know him very well, but very briefly, he is a professor emeritus at ASU.
Or U of A, but it doesn't matter.
And he's going to talk to us about repair and retrofit of civil structures using fiber reinforced polymer. But before I let Dr. Asani get started, I want to let you know that the next session, the next webinar, which is going to be on 25th of August, it's going to be on a very interesting subject of surge control in water distribution and pumping. I had a hard time finding the right person to talk about this because many cities in Arizona have the need for this subject. So it's going to be on 25th of August at noon. Also, just to let you know, this session will earn you 1 PDH. And I think Dr. Asani is going to talk about that. But with that, I'm going to let you go, Dr. Asani.
Thank you so much, Michael. Thanks everyone for attending. And I want to make sure that we stay on time. And because this is a 1 credit PDH, so we have to stay together about 45, 50 minutes. So, but we should be out by 1 o'clock. There is in the chat room, there is a form that you can see. You can download it if you'd like. And that is a form that we require that you fill out and sign in your own handwriting. So we keep it as a record, and then we'll email you your PDH credit. Okay, so let me just jump into the presentation, which is today. Mostly we're really going to be talking about our pipeline repair and construction technologies today. So briefly, just a little bit about our company. We're kind of really an unusual mix. We have not only an engineering design company, but we have a manufacturing component. We develop and a lot of patented technologies. Then, as I said, in the manufacturing part of the company, we make these things. And then we also have a construction company that does the installation. So a lot of times we do these design build projects. And as you see, some of the projects that I'll be sharing with you today, they're in the same vein. But it is good for you to know as a background that if you want to team up, these are some opportunities where we can hopefully bring in some creative solutions to your projects, and if needed, install it with our own crew. So here is a list of, we definitely have a lot of unique products. I think, overall we have some like 20 patented techniques, about 6 of them relate to pipelines, and a bunch of government grants. So I won't bore you with all of that stuff, but the two companies, the Quake Wrap and our construction are combined. We have about roughly 50, 55 employees. So let me look at, like these FRP products that we're talking about. Of course, they've been around for decades. Initially, like you see some of the Corvette bodies were made in the 50s with these, extensively used in marine and aerospace industry. In fact, this Boeing 787, the Dreamliner, everything you see in gray, which is about 75% of this aircraft, is made out of carbon FRP. So they're not so much novel and new anymore. And even in pipelines, we have been using fiberglass pipes for decades. And what we are doing here is basically an extension of those, a better version of those fiberglass pipes. So, when it comes to pipe rehabilitation, these are some of the factors that you need to consider for every project. The time that it takes to repair, the cost of the repair, the difficulty of installation, especially if you're in some municipality or some urban areas, the reliability of the system, how long it is going to last. After the repair, how serviceable it is, whether you can have connections to it, or if you have to make any modifications, how easy or difficult it is. Permitting of the construction, especially if it requires some digging and trench cutting, that would be adding a lot of challenges, which with some of these solutions that we show you can eliminate. And another factor is like the hydraulic capacity. So most of these repairs that we do with carbon, because the liner is so thin, and you also, because you end up with a very smooth surface, you oftentimes improve the flow characteristics of your pipe. And the bottom line is the value that obviously everybody wants to get the most bang for the buck. And I think, as you see, a lot of these projects do serve that purpose. So there are two, when it comes to pipe rehab, there are really two different techniques. One is to dig and replace, which, as you can see in this slide, it requires a lot of laydown area construction and heavy equipment on site, environmental challenges, and disrupting potentially like traffic if you're on a street or what have you. And of course, the pros are that it uses the materials that have been around for decades and are well understood. When it comes to trenchless technologies, the advantages are that you usually don't require any trench or a very minimal access point. So social costs are much more appealing, and you have also a much smaller carbon footprint as a result of these smaller equipment on site and less digging and so on. And of course, on the negative side, you need to know what you're doing, and the quality of installation becomes very critical. So these FRP products that we use, the acronym FRP stands for fiber reinforced polymer. And as I've shown here, the polymer that we use is the red here, shown in color red. This could be either a polyester, vinyl ester, or epoxy. We usually use an epoxy matrix. And then the fibers shown here in white, they are either carbon or glass. These are the two common ones that we use. Kevlar can be also used, but not much in construction. So as you look at an FRP material, these are non-homogeneous because you have the carbon or the glass fiber and then the resin. So they're two different materials. And the other feature of these is that they are anisotropic. Basically, that means that the strength of FRP comes from the amount and orientation of the fiber. So unlike a steel plate that you get the same strength in X and Y direction, with FRP you don't. You get different strengths depending on the orientation of the fiber. And this feature of it is really, as you'll see, it becomes a pretty nice feature, especially when it comes to like pipeline projects. So let me just, let's say as an example, if you have a layer of carbon fabric, this is a typical carbon fabric that you can get from us or any other supplier. Say it has a thickness of about 0.05 inch and it has a breaking force of about 6,000 pounds per inch in the direction of that arrow. If you're going to repair a pipe and line a layer of this carbon fabric inside of the pipe, let's say this is a 24-inch pipe. So you cut a free body diagram, you see you get 6,000 pounds for every inch length of this pipe. You get then a nominal pressure cap rating of 500 PSI on a 24-inch diameter pipe with one layer of this fabric. And if you add another layer, it becomes 12,000, so you double that, you get 1,000 PSI. So one of the questions that we often get asked from engineers is that how high of a pressure you can design these pipes for. It's really almost like endless, because the more layers you add, the more pressure rating you can achieve. And of course, in doing this type of work, you notice that how little we are adding to the thickness of the pipe or liner, as well as to the weight of the pipe. So it is, these are some of the benefits of FRP products. I just wanted to show one slide here that we continue to do a lot of product development. We have our own research and development lab here, where we have currently a couple of government grants that we are finishing, one with the oil and gas industry for spot repair of transmission lines, and another one with like this infinite pipe. So we continue to develop, and in fact, sometimes for a specific project, we test some of the materials for that. So again, to summarize the advantages of these FRP products for pipelines, they have very high tensile strength, typically 2 to 4 times that of steel. This anisotropy that allows us to orient the fibers, for example, in the hoop or longitudinal direction, that's a major advantage. The materials themselves are non-corroding. We can create a watertight membrane to stop leakage in the pipe, as well as increase the pressure rating. And because they are so flexible when they are applied, they fit all shapes and sizes. And you see examples of some of these projects that we've done. That's really a major advantage, that you don't need to build your liner ahead of time. And some manufacturers, including us, we have NSF 61 certification for our system for repair of potable water pipes and tanks. In terms of design guidelines, really much of this FRP, which I was involved since the early days in the late 80s when we introduced this, much of that development initially was done in the concrete industry. So there was this ACI Committee 440 that I was a founding member of it back in the 90s. And that committee has developed these design guidelines. And those are really pretty much the Bible of the design for that, and they have made their way into the pipelines too. On the mechanical side of things, there's an ASME PCC2 repair of pressure equipment and piping that they are also developing some design guidelines for pressure pipes, but mostly in the mechanical world. AWWA has a committee that they just C305 report that they published about couple of years ago, and they're now going through a revision of that. This is for pre-stressed concrete cylinder pipe repair with FRP, specifically for pre-stressed concrete cylinder pipe, because that seems to be one of the major initial applications of these in the water industry. And then more recently, NASCO has developed a guideline for sewer rehab. And in fact, Farad, our pipeline division manager, he chaired this committee, and they just published this new guideline for repair of sewer pipes with the FRP. So there are some of these are basically coming along in different industries now. So the first one of techniques that I wanted to talk about, like 2-3 different techniques today. One of them is, the first one is wet layup. Wet layup, which is the basic of all of these things. Basically, you have rolls of fabric, like you see here in the upper left, that go through a saturating machine. We saturate them with the resin. The fabric is taken up on that take-up reel, and then we pass the fabric to the crew, either through a manhole or access point, and then they apply the fabric layer by layer to the surface of the pipe in the design orientation of the fibers. Some of the very earlier applications of these, in fact, they were done in Arizona. This is something that we had done ourselves in in the shutdowns at Palo Verde nuclear power plant in fall of 98 and 99. We repaired some 108-inch diameter pipes for them. These were in the recirculation cooling system of the plant. And these are, again, pre-stressed concrete cylinder pipes. A lot of these pre-stressed cylinder concrete pipes, they're having their wires corroding and breaking. And so there are companies that monitor the breakage of these wires. And once you achieve a certain number of breaks in every, say, like spool of pipe, then the owners decide that that's the time where you have to rehab those. So these, again, the liners can be applied on the inside of the pipe. And that's actually a picture of a younger version of me some 20 plus years ago, when I was in Palo Verde, and we were trying to show how many layers we could stick to the surface of the pipe without it falling down. So some typical applications of this is a job that we had done a few years ago in Costa Rica, where the government of Costa Rica had built this power plant, and the penstock for this power plant was a almost like 1.1 mile 7-foot diameter concrete pipe. And because they didn't have a heavy pipeline construction industry in Costa Rica, the contractor built the pipe on site. And when the plant was done and they tried to turn it over, they put water in it. It was like a sieve. They had millions of holes in it, water leaking everywhere. And so they emptied the penstock, injected some resin in there. And then as soon as the pipe was pressurized, again, those cracks would open up, mainly because you didn't have enough reinforcement in the hoop direction. So, that was the issue with this job. And of course, you have another concern that this is a sloping terrain. So this point here is the upstream is like at the top of the mountain at the reservoir. And then the bottom of the pipe the other end is at the bottom of the mountain where we have the turbine. So there's a sloping terrain also. So we sent for this thing, we sent our crew and, including several of our guys who were Spanish speaking, flew them to Costa Rica and flew the material. And very quickly, along that pipe, there are 4 access points about 2 feet by 2 feet that you can see that opening. So we set up 4 different crews outside of the pipe, each crew basically doing almost like a quarter of this pipe. And that's something to keep in mind, that on a large job, you could have multiple crews and that would expedite the repair. So the guys outside would saturate the fabric, pass it to the crew through that opening, and then inside we had runners that would run back and forth to give the material to the crew, and then they would apply it. And then we provide details for the overlapping joints. You can see them in the hoop direction. They're the darker colors where the fabrics are overlapping. In this case, for example, every band of fabric was 50 inches. So we have like 4 or 5 inches of overlap in the hoop direction and also along the length of the pipe. A couple of more jobs closer to home. This is for Salt River project in Arizona at the Mormon Flats Dam. This Penstock is about 90, by now 95, close to 100 years old. And you can see the construction of it, those pictures that they were bringing the pieces of the Penstock. So the area that we were required to repair are up here in the, here you have the 2 96-inch steel riveted pipes that connect together in this Y section, become 120-inch diameter. At the same time, they drop vertically by about 20 feet, and then it becomes horizontal and goes into the powerhouse. So this area was corroded and required some repair or replacement. The replacement cost was just so expensive that they couldn't really afford to do it. So we provided the repair internally. And I just have a couple of pictures of, so we had to set up a scaffolding and reach in there. But I just wanted you to see, for example, here that how some of these, like at the Y, where you have this fin coming towards you and very complex geometries, that's another advantage of these FRP systems, that you can wrap them inside of the pipe and they conform to basically the geometry of the host pipe. This job was done about 3-4 years ago now. These are, this same system can be done externally. These are some projects from Atlanta Water and Sewer Department that we are repairing some 48 to 72-inch diameter pipes in their processing plant. And, again, you look at like the complex geometry of this pipe, for example, which is partially embedded in concrete. And so we had to come up with some details of how, when we wrap the outside of it, how we anchor the FRP into this concrete to achieve the full capacity of the pipe. But those can be done. Again, these are some process pipes that can be coated, while the pipe remains in service. That's another advantage. So these are, because they're also outside in the open space, we provided a UV protective coating on the outside of the installation. And the liner is designed to take the internal pressure without any leak. This was another job we did, I think, about a year or less than a year ago for Fort Worth, Texas, where this is a water reclamation facility. It's the internal lining of this case was a untreated or sewer pipe, but we could do the same thing with our NSF 61 certified material for a water pipe. Basically, any pipe that is typically, our guys are smaller guys, they can go into pipes about 30-inch in diameter. Anything less than that, they don't really like to get into it if it is too long of a stretch, but 30 or 36 they can do. This is another riveted penstock. And I wanted, again, just to focus on really on this one, on the, when we have these riveted penstocks, keep in mind that, from an engineering point of view, when you put that carbon fiber, you need to make sure that there is no kink in the fiber, because otherwise, when you apply the pressure to it, the first tendency would be to get rid of those kinks, and that doesn't take any of the load. So when we have a riveted pipe like that, we have to make sure that we trowel and epoxy over all of those rivets to make sure that it becomes feathered and smooth, and then the layers of carbon are applied to it. You know, here you have some branches that are coming off, plus some reducers, and then at the far end that you don't see, there's a valve there. So it's really complex geometry, multiple diameters, and as you can see, you know, this repair is done here, very nicely done, and then, you know, the finished product can be seen here. And I wanted to point out here that this, what you see, is a Weco seal. Usually at the leading edge of the repair, you want to make sure that you apply, provide a detail that doesn't allow any water to get behind the liner. So one way for steel pipes would be to use that Weco seal to apply a compression seal like that. For some other pipes, like, you know, here, this was a project in Arizona, coaches, that we were doing I think it was for us, was this a 102 inch, I think, diameter? It was 96 or 102 inch, but it's a large diameter pipe. But in this case, you know, this is again, if you have a steel can and you're trying to terminate the end of your installation, you know, we don't want to have carbon fabric to come in contact with that steel can, because that causes corrosion. So we apply a layer of glass fabric as a dielectric barrier, and that's what you see here. Now, the other layers of carbon would go on top of that and, you know, create that end seal. A lot of times, you know, I know we don't do a whole lot of jobs, actually, maybe more, not enough of our share in our own state of Arizona, but we get calls from all over the country. This was a 48 inch emergency pipe repair in Baltimore that we did a year ago. And so here you see some of the repairs of that pipe and the end again, you know, the termination, near the termination point. So oftentimes we get these calls and, you know, fly the equipment and the guys over there in 48 hours to finish the job. That termination, end termination that I was mentioning, this is a critical point, and I want to show there are various ways. Like on the upper left here, we have a Weco seal that we are using. So that goes over, like if you have the end of the laminate here is shown here, then you would have a layer of thickened epoxy applied to it, and then the Weco seal kind of bridges over that and, you know, provides a tight seal. There are other ones. The other ones, like, you know, we can cut a keyway into a concrete pipe and embed it in there. Or if you have a bell and spigot joint, there are standard details. In fact, the AWWA C305 has some of these similar details in there. I don't want to get into all of the specifics of it. You know, if you have a specific job, you can either find it in C305 or, you know, contact us and we have the right details for such applications. Another really advantage of these FRP products and that anisotropy feature is that you can orient the fibers in the direction that you want so that they can take any thrust in the pipe as well. So by orienting the fibers along the length of the pipe, we can create a significant thrust resistance in these pipes. Same kind of concept that you see in pipes, it can be used to repair storage tanks, whether it is for, you know, water or oil and gas or other minerals, like in the mining industry. But you know, we can apply the carbon either on the inside of the tank, if it is acceptable, to create a watertight and basically like a pressure vessel inside of the tank, or they can be applied on the outside, and we have examples of both of these. So here on the top, there's a job we finished last year for the US military in Manila, Philippines, where there are two of these large tanks in the, if you ever look at the Google map, it's a very interesting site, the US military cemetery in Manila. It's a beautiful cemetery. And they have, you know, two water, you can't see the water tanks in there because they're partially buried underground, but there's the cemetery is beautiful. And so these two tanks, you know, we repaired those last year. On the lower left, there's a tank in a mine in Nacosari, Mexico, where these tanks hold sulfuric acid in the mine. And so the conventional, like with the steel rebar was corroding severely. So we repaired those with the lining. And then on the lower right is actually an ongoing project right now that we are doing in Dominican Republic with a potable water tank for the municipality. And you see the crew. This picture was as of actually a couple of days ago. So, and I just wanted to include this so you see that we do go outside of Arizona to do some of these projects. This one is for a mine in Arizona, and this is where we were repairing the tank from the outside and wrapping it from the outside to create the strength that is needed, as well as making, prevent any leakage. The other thing that I wanted to talk about is this stiff pipe, and what this, let me just tell you how we came about this thing. We are finding out that a lot of our clients are nowadays requiring us to provide a liner that is not only good for internal pressure, but it can also resist external loads. So for internal pressure, 1 or 2 layers of carbon is typically more than enough to take all of the pressure. But when it comes to external loads, the rigidity or stiffness of the liner matters. So if we wanted to use many, many layers of carbon to achieve, make a thick plate of high rigidity, like some of our competitors are using, that becomes really expensive and cost prohibitive. And that's why we developed this alternative. So in here, for example, let's say if I have 2 layers of carbon fabric shown in this slide, and let's just say hypothetically a layer of carbon fabric, installed cost, say $30 a square foot. So here we have 2 layers of it, is $60 a square foot. Now, if I put something in between here, a lightweight material, and stretch these two to the thickness of 2T, I'm still using my green area, which is that carbon fabric is about the same as before. So I still have like $60 for the carbon, maybe a couple of dollars for this filler material. But you see my rigidity stiffness becomes 7 times more. And if I stretch them farther, I get significantly higher stiffness, but without adding much cost. That's really the whole concept, that we can make like an I-beam achieve a lot of rigidity. And one of the ways to do that is with this 3D fabric. This is like a particular fabric that has 2 layers that get saturated together. And during the curing process, the top layer rises from the bottom layer, creating a series of web like I-beams. So you get a very lightweight and rigid material, and you could have like carbon on the top and bottom surface of this. So this is one of the materials we can use as a core for the pipe that we make, and I'll show you in a minute, but there are other materials also. So in this stiff pipe, the wall of the pipes is made out of a lightweight core material like the web of an I-beam, and then we use glass and carbon fabric on the extreme surfaces. Typically, the carbon fabric goes on the inside to resist the internal pressure, and then the honeycomb and that glass layer on the outside provides the overall rigidity of the pipe. We can make this pipe in any shape or size. It doesn't need to be circular, and it is used in 2 distinct ways. One is for making a pipe segment and slip lining a deteriorated pipe, and the other one is to use the wet layup system and build kind of like a stiff pipe directly on the host pipe. And I have examples of both of these to show you. So to make this pipe, we can use a relatively easy to manufacture mandrel with telescopic arms that come out, and we can make, extend these to the exact diameter that we want, put a skin around the mandrel, and then the layers of carbon and that core material are wrapped around the mandrel. And once it is done, we let it cure overnight. And so by the next day, you have a piece of pipe completed. Then we collapse the mandrel, remove the pipe segment, as you see here. These pipe segments are very lightweight. Here is like a 48-inch by 4-foot long piece of it being picked up by then my 16-year-old daughter back then. so they're very lightweight. And then, in installation, this was, for example, this is a force main for a sewage treatment facility, Avalon pumping station in Southern California. the steel pipe, host steel pipe, was 48 inch in diameter. And we custom made these stiff pipe segments so that the outside diameter of the pipe was 47 inches. So you can hardly see it, but this is actually lined with our pipe, and only like a half-inch annular space that was filled with resin. This is, again, really one advantage, that you can custom make these and you reduce your flow loss in such applications. This whole pipe system I received a few years ago, the ASCE Innovation Award, as the world's first green and sustainable pipe. And we've really used it not only in like some of the projects that you saw here, but we've used it on some crazy project. This is one ongoing job that I think we're set to set some records nationwide, if not globally. This is a 17.5-foot diameter tunnel in Detroit for Oakland, Macomb County sewer facilities. And we are, the tunnel is deteriorated. So this is one of the systems that they're using on that project, our pipes, to line the deteriorated tunnel with a 16-foot diameter pipe that we are making very close to the job site. So remember, you know, if like the only company that makes any non-metallic pipe, the major ones are like Hobus and Flowtight, and these folks have plants in southern states like Texas and Louisiana. But this job is in Detroit. So even if they could make a pipe of this diameter, you couldn't ship it to Detroit. We are making this about 70, 80 miles away from the job site. And the pipe is so lightweight, even at 16-foot diameter, it only weighs 450 pounds per foot. You know? but it is a fully structural liner, and it would be installed without bypassing the hose pipe, and it has a bell and spigot joint at the end of it, so they would be just snapped together. So it's quite a really interesting project, and the pipe segments are nearly done, and I think the contractor is probably going to start installing these in about 6 weeks or so, 4 to 6 weeks from now. This is a video of how the pipe is being made by wrapping the layers around the mandrel and applying, you know, this is carbon layers and the resin. So that's how we are making it close to the job site. That pipe, by the way, 16 foot in diameter, the wall thickness is just less than 2 inches, slightly less than 2 inches. And as I said, another way is to use this stiff pipe and apply it directly to the surface of the pipe. This is a tunnel in Minnesota that we did a couple of years ago under I-35, 12-foot diameter tunnel. About, you know, from the shaft that we would go into the tunnel, there was about 3,500 feet of distance to get to that repair area. So you can imagine there's no way you could have taken any pre-manufactured pipe in there. But the material, raw material, including the core, they were taken in, and then the crew traveled to the point of repair and built, applied layer by layer directly on the hose pipe. And the lower right, it shows you nearly as we approach the finished project. Again, on a 12, you know, this was like a 12-foot diameter pipe, and the total thickness of our fully structural liner was less than, you know, around 1.25 inches, 1.5 inches in that range. When you do this multi-layer system, you want to make sure that you have a very good bond to the hose pipe. And so this is one of the things that we do. We test these, you know, this is a pull test that we are doing to make sure that as we pull this away, and I don't know if you can see it or not, but these are like typical samples that we pull out of this thing. So the pipe is actually, you know, everything is stuck together. It doesn't come apart. It breaks the concrete from the hose pipe. The last thing I want to focus on here are these for small diameter repair. So, you know, for small diameter repair, we have developed this SuperLaminate, which is basically, we can apply various layers of glass or carbon in whatever orientation we wish, and apply heat and resin to it. And in the process, we make a very thin laminate, as you see in the upper right, you know, some samples of it. These are extremely strong, especially because they're being manufactured under, you know, good quality controlled environment in our facilities. And they can, go up to like 150,000 PSI tensile strength on some of these. So here are some applications of this, like in this case, we have the grant from US EPA for repair of water main. So let's watch this thing together.
Introducing SuperLaminate, the world's only no-dig water main point repair system exclusively from QuakeWrap with support from the US EPA SBIR program. Using a remotely controlled packer system, an underground water main pipe with a crack and leak can be quickly repaired. Simply close the valves and drain the pipe. Apply epoxy to SuperLaminate. Then wrap the packer with SuperLaminate. Deploy SuperLaminate through a fire hydrant between the valves. Once at the damaged section, inflate the packer to expand the SuperLaminate and start the curing process. Then deflate the packer and pull the system back through the original access point. The water main is now returned to service with the break repaired using SuperLaminate and no excavation needed. For more information, contact a QuakeWrap engineer today.
So this is, something that we are also extending this system with some more development with a major grant we have from US DOT PHMSA, the Pipeline Hazardous Materials Administration, that we are developing this for spot repair of oil and gas pipes. So we are in the second phase of a project, and with a $1 million budget, we are in the year 2 of it now. And Farhat and his team and our R&D lab, they're heavily involved with testing and developing that. So that should be finished in the next 8 to 10 months and coming out to the market for those types of repair. And then the last thing I think that I have here is like this infinite pipe, which is something that we developed with another grant from the government, thanks to your tax dollars. So they're going to good use. So you see here, but this could have some potential on maybe some of your projects.
This video shows a simple method to build a continuous infinite pipe on site. The process has been developed by QuakeWrap engineers according to Professor Asani's patented technique. Funding for this development through SBIR grants from the U.S. National Science Foundation and the U.S. Department of Agriculture is gratefully acknowledged. A heated, collapsible mandrel is provided. Layers of carbon or glass fabrics saturated with a special epoxy resin are wrapped around the mandrel. The strength and stiffness of the pipe is dependent on the type and number of layers of fabric being wrapped and will be designed by QuakeWrap engineers for each specific project. The mandrel is heated, and within a few minutes, the pipe is fully cured. Next, the mandrel is partially collapsed, and the finished pipe segment is pulled away, leaving a short segment of the pipe on the mandrel. Additional layers of fabric are similarly wrapped, cured, and the finished pipe is pulled away. This process continues for as long as needed to build a jointless pipe of desired length. The pipe can be used for new construction, for slip lining existing pipes, or for casing of wells. Advantages of infinite pipe include highest strength to weight ratio of any pipe, non-corroding materials with long service life, no cathodic protection is required, designed for any pressure, virtually no transportation cost, construction begins immediately upon placement of order, weighs less than 10% of conventional pipes. Infinite pipe is a green and sustainable technology. The 12-inch diameter pipe shown here has a wall thickness of only 0.18 inches, and it weighs about 4 pounds per foot. The pipe can resist an internal pressure of over 900 psi. The pipe surface is as smooth as fiberglass or PVC pipes. While the technique shown is ideal for projects with limited access, An automated wrapping machine is currently being designed for manufacturing larger diameter pipes. For more information, visit us on.
So yeah, so this, as the video indicated, like for that particular pipe that you saw, it's really lightweight. It's only like 2.5 pounds per foot, and the materials cost, like that thing that you saw, it's it's probably now with prices having gone up, maybe it's like up to $8 or $9 a foot. But basically the materials cost, because we are using glass fabric in that demonstration, and it's really, as you see, it's really not that much, and it can still resist a lot of pressure for relatively very little investment. I wanted to mention another thing that I forgot, that stiff pipe that we make, the consultant that has specified us for that job, in Detroit that we are using, they're so happy with having seen those 16-foot pieces of the pipe that now they have a new construction of a new 1 mile long, 54-inch force main pipe for a sewer treatment project, and they have specified that pipe as an alternative for that project. So it is really becoming like a new type of pipe to be used in some new construction projects also. So with that, I was hoping to make sure that there's some time left if you have any questions, but these are my contact info, myself or Farad, any of us, if you want to call us or contact us, we'd be happy to team up with you on any of your projects.
So yes. I guess do most of your applications in drinking water or sewer, or both?
Both, really. I guess we have done both. I mean, a lot of maybe, I don't know if you want to say there are water pipes. They may not have been, we have NSF 61 certification, so we can do a lot of, any water pipe, 8-inch diameter and larger, but it just seems like, in terms of volume of what we have done, if my memory serves me right, like all of these big Penstocks that we do, these are, not necessarily drinking water projects that we are doing, but so, and I know we have done a lot of recently. I think Farad is more, and John, them too. We've done a bunch of sewer projects in Phoenix, in fact, lately with you guys, with Dibble, on some of those jobs.
So do you also do a lot of reservoir renovations, concrete reservoirs?
Yes, concrete reservoir. If you're like the one that we are currently, it's ongoing in Dominican Republic, that's the case. In the mines, those are concrete that are dilapidated concrete. We have repaired for them. The one in the 2 big tanks in Philippines. Yeah, I mean, there are all kinds of applications for those. Yes.
Okay. And one of your first slides mentioned your CIPP capability. Do you do that as well?
Yes, CIPP, so that is really one of the, in fact, in water applications, that was probably out of necessity, because these CIPPs were breaking and blowing up in different facilities. So it was really the application of carbon FRP in pipeline repair. It started, I think, out of necessity in the late 90s in CIPP pipeline, and then now it has worked its way to other types of like steel pipes and other materials.
Okay, thank you.
Sure.
So yeah, we have a few minutes left. John, you have any questions or any issues to talk about?
I just had one question, and that was, go ahead.
No, I just saw one of in the chat box that somebody is asking if they could, where they should email. John, I think you're asking. So you could send, if you want to send this, I'll put in the email office@quakerap.com. If you can email for PDH units, that form, you can email either to me or send it to office@quakerap.com, and it will be processed. It takes us a few days, but we'll keep a log of all of these attendees, and then you'll get a certificate in email.
Have you done a lot of reservoirs in Arizona or with various your various municipalities?
Yeah, there are. I mean, there are really. We hear about some of them. I know in Tucson they have had some that they have fixed, and I don't. You know, we haven't really done any of these other than a mine in Arizona. I
So
don't.
Let me jump in, Michael. By reservoir, do you mean like an open reservoir, or just storage tanks?
I'm talking like huge storage tanks in the ground.
Yeah, we have done quite
concrete. Yeah.
Yes, we have done quite a few storage tanks, steel and concrete. But in terms of like an open reservoir that is like, say, hundreds of feet long and wide, that kind of project, the Mexican project that Mo presented would be the closest thing, which was a sedimentation basin. So I don't see a huge difference between the two. If it's an open reservoir, we would probably apply a UV protectant coat. There's a difference between a storage tank and an open reservoir.
And you can apply additional coating on these easily?
Yeah, if like these materials, one thing really I should mention that this is one of the advantages of FRP products is that if you have a damaged area, for example, they are much easier to repair and patch compared to like conventional materials. So let's say typically, if you had a badly damaged area, all you need to do is go roughly about a foot on all sides around it, scuff that up, and then apply new layers of fabric saturated with resin over that damaged area, and you can restore the full capacity of your structure. So it's really, they're very forgiving in terms of their repair compared to, other things.
Okay.
If any of you are an avid bike rider or carbon bike, you know that those things, or skis or whatever, when they break, it can be easily patched up.
Yeah. All right. Well, thank you, Mo, and thank you, Farad. This was very informative. I appreciate it.
Thank you.
And I'm guessing if we get to your website, we can get more specifications.
Sure, yes. They go to either QuakeWrap or that pipemedic.com website, either way, and yeah, we look forward to, collaborating with you. And again, we really have a lot of out-of-box solutions. So if you are thinking some projects that maybe you're scratching your head, does this, does it work or not? It's a free consultation. So think of us as a resource for yourself, and let us know. And if we can help you, that'd be great.
Okay. Well, thank you so much. I appreciate
Thank you all. Yeah, we appreciate it. Have a good to see you, everyone. Have a
see you guys again. Bye-bye.
Take care. Bye-bye.